Hey students, in this video we're going to cover the sum and difference formulas and like the double angle formula. So you'll need a calculator. We are going to use that a bit. Most of this is going to rely on your knowledge of the unit circle and the special angles. In degrees, our special angles are 30, 45, 60, the multiples of pi over 2, and the multiples of pi. So we're talking pi over 2, 3 pi over 2, pi, and 2 pi. In radians, of course, that's going to be pi over 6, pi over 4, pi over 3. I'm sorry, I should have put 90 right here. 90, 180, 360. Oh, I left out 270. So in radians, those will be pi over 2, pi, 2 pi, and 3 pi over 2. You need to know the sine, cosine, and tangent values of those angles. It will be helpful if you memorize them. So the sum and difference formulas are just formulas in trig that help you break down angles, generally that are not special angles, using the sum or difference of two special angles to get their values. It is not necessary that you memorize these. You will be given them anytime you have to use them. You just have to know how to use them. So for example 1, we have to find the exact value of 105 degrees. So when you come across a problem like this, you want to see if you can use any of the special angles to get 105. So there are a couple ways that we could do this. The easiest way is going to be 105 degrees is equal to 45 degrees plus 60 degrees. And we want to find all of the trig values for 105 degrees. So if we did sine 105, so we're going to have the sine of 105 degrees. Now, according to our formula, let's label these. So we'll use we'll say 1, 2, 3, 4, 5, and 6. So the sine of a sum is going to use formula 1. So that's just going to be the sine of 45 plus 60. So that's going to be the sine of 45 times the cosine of 60 plus the cosine of 45 times the sine of 60. And you just keep simplifying from here. So on a unit circle, the sine of 45 is square root 2 divided by 2. The cosine of 60 is a half. Yep, it's a half. And the cosine of 45 is square root 2 over 2. And the sine of 60 is square root 3 divided by 2, not 3, almost ordered 3. So divided by 2. So if you simplify, that's just going to be the square root of 2 divided by 4 plus square root 2 times square root 3 is the square root of 6 divided by 4. So you can simplify this to be the square root of 2 plus the square root of 6 divided by 4. And that is not the square root of 8. This is as far as we can simplify that. So then the cosine of 105 degrees. So then cosine, let's do it in a different color so that we won't blur stuff together. Nope, you just wrote stuff, you didn't erase stuff. So then, Mr. Moore, you struggling today. So cosine of 105 degrees. So now if we're doing the cosine of a sum, then we're going to just use the third formula. So that's going to be cosine of 45 plus 60, which according to our formula is cosine 45 cosine 60 minus, that should be sine, so minus sine 45 sine 60. Now again, exact values using the calculator will not cut it. So that's going to give us, let's see, cosine of 45 is square root 2 over 2. The sine of 45, I'm sorry, cosine 60 is a half. So root 2 over 2 times a half minus the sine of 45 is square root 2 over 2. The sine is square root 3 over 2. So that is going to give us the square root of 2 over 4 minus the square root of 6 over 4. And that's going to be root 2 minus root 6 divided by 4. Now that value is negative, and it makes sense that the value is negative because 105 degrees is in quadrant 2. So we expect to get a negative sine value, and we expect it to get a positive we expect to get a negative cosine value, and we expect to get a positive sine value. And so the last one is tangent, and tangent is going to be a bit more work, but it's going to use formula 5, and we'll do that in, I don't know, some color that's not red or blue. We'll use this darker blue. Ooh, good blue. It's almost black, but not quite. So then we have tangent 105 degrees, and we're just going to use this fifth formula because we're adding our two angles. So that's going to be tangent, we'll skip the a plus b part. A is going to be 45, b is going to be 60. So it's going to be the tangent of 45 plus the tangent of 60 divided by 1 minus the tangent of 45 times the tangent of 60. Now the tangent of 45 is 1. The tangent of 60 degrees is, you got to know the unit circle, it's the square root of 3. And then divided by 1 minus tangent 45 is 1 times the tangent of 60 is square root 3. Square root 3. So that is just 1 plus square root 3 divided by 1 minus the square root of 3. All right, that is it for the 3 trig functions for 105 degrees. Now, of course, we could do secant, cosecant, and cotangent just by doing the reciprocals of each of those. We're not going to do that. I feel like that's just an algebra 2 thing at that point to simplify those. So we're going to stop here. For example 2, we have to evaluate the expression given the 2 trigonometric values of the angles. We have to find the exact value of sine A plus B, knowing that A is in quadrant 2 and B is in quadrant 3. And we know sine A is 9 over 41, cosine B is negative 3 over 4. So let's draw angle A. So angle A is in quadrant 2. So we'll say like this is angle A. Cool. So now if angle A has a sine of 9 over 41, we'll make our right triangle here. That means this side is 9, the hypotenuse is 41. What we can expect then, if we did the Pythagorean theorem, which I'll leave you to do, is we're going to get that x side, the horizontal side, is negative 40. We're going to need that. And so then angle B is in quadrant 3. Let's do that in a different color. Let's go with light blue. So now angle B is in quadrant 3. So it has a cosine of negative 3 over 4. So let's go all the way over here. So we'll say this is angle B. So that is angle B right here. And if the cosine is negative 3 over 4, that means that the x side is negative 3, and the hypotenuse is 4. Yeah, we'll just go with that. I didn't feel like doing the Pythagorean theorem. So to find the side, the vertical side, we would have we'll say y squared. Y squared plus negative 3 squared equals 4 squared, which is 16. So y squared is going to equal 7, and y equals plus and minus the square root of 7. Now, since that value is in quadrant 3, that's going to be negative square root 7. Cool. All right, so all of that is just so we can eventually get to the sine A plus B part. We're going to need the cosine and sines for those opposite angles. So we know the sine of A plus B, according to our formula, is sine A cosine B plus cosine A sine B. So we know the sine of A is 9 over 41, and we know the cosine of B is negative 3 over 4. So the first part of that is taken care of. But then the cosine of A and the sine of B. So the cosine of angle A is going to be negative 40 over 41. So that's negative 40 divided by 41, because we can use the reference angle here. So adjacent over hypotenuse is going to be the cosine. And then for B, the sine is going to be negative, is going to be negative root 7 over 4. So times negative square root 7 divided by 4. I have no idea what any of these numbers are. Well, 41 times 4 is 164. So 41. So we end up with negative 27 over 164 plus 40 square root 7 over 164. And you could just make that 40 square root 7 minus 27 over 164. That's the final answer. Now, what we did here was we used the sine value to draw a triangle to find the cosine value, and we did use the cosine value for angle B to make a right triangle, use the Pythagorean theorem, and to find the missing side for the bottom triangle. So then for example 3, we have to find the solutions for this trigonometric equation. So we have sine plus sine x plus pi over 3 plus sine x minus pi over 3 equals negative 1/2. That's going to be, again, sine of a sum. So sine x cosine pi over 3. So we're going to break this thing down into two things. Sine x cosine pi over 3 plus cosine x sine pi over 3. And then, so that's all for what we did in blue. Now in maybe red, for instance, we're going to break the sign of a difference down and get sine x cosine pi over 3 minus cosine x sine pi over 3. All of that is from the sign of a difference, which again is just the second formula. And all of that should equal negative 1/2. Well, conveniently for us, the cosine x sine pi over 3 and negative cosine x sine pi over 3 cancel out. So we end up solving the equation 2 sine x cosine pi divided by 3 equals negative 1/2. So the reason we get 2 sine x cosine pi over 3 is that we have one here and we have another one here. So cosine of pi over 3 is 1/2. So this is just 2 times sine times 2 sine x times 1/2, which is 1. So we end up with sine x equals negative 1/2. Now again, that's because the cosine of pi over 3, that is equal to 1/2. So now we're looking for where sine x equals negative 1/2. So according to we don't have any restrictions here. So we're going to say x is equal to sine inverse of negative 1/2, which is negative pi over 6. So negative pi over 6. And we'll talk more about this in class, but it's just negative pi over 6 right now. So that is our solution. For number 4, example 4, we have to simplify the expression tangent theta plus pi over 4. And so we're going to use this sum formula here. So tangent theta plus pi over 4. So the sum, like if we're doing the sum of tangent theta plus pi over 4, that's going to be tangent theta plus tangent pi over 4 divided by 1 minus tangent theta tangent pi divided by 4. And that simplifies to be, so we don't do anything with the tangent theta. Tangent pi over 4 is 1 divided by 1 minus tangent theta. Excuse me. So that is it. So we could stop here. Is that going to be the good place to stop? If we did 1 plus tangent theta, we get 1 minus tangent theta squared. Yeah. We'll stop right here. All right. So that is good enough for what we want to do. So now what the use of this is that the tangent value now is defined just by the angle theta and not the plus pi over 4. So that's useful. So now the last example of these sum and difference formulas is we're going to show that sine x plus pi over 2 equals cosine x. So we'll just use the sign of a sum again. So that's going to be sine x cosine pi over 2 plus cosine x sine pi over 2. And we have to show that that equals cosine x. Fantastic. So now the cosine of pi over 2, remember on the unit circle, cosine is an x value. And pi over 2 is 90 degrees. So pi over 2 is right there. And the x value when you're on the y-axis is 0. So this is sine x times 0 plus cosine x times. Now remember on the unit circle, the highest you can go is 1, and the sine is the y value. So here at pi over 2, you're at the point 0, 1. So that means that the sine of pi over 2 is 1. So you end up with just cosine x times 1 equals cosine x. So we verified that identity. Cool. All right, so all of that is the sine, like the addition formulas, the sum and difference formulas. All you need is the formulas to do this, and again, you'll be given them. You just have to substitute them in. For the double angle formulas, so sine of 2 theta is 2 sine theta cosine theta. Cosine 2 theta has 3 different formulas, and they're all based. So remember that identity: sine squared theta plus cosine squared theta equals 1. You can manipulate that equation to, of course, get so here we could manipulate this to get 1 minus sine squared theta equals cosine squared theta. And so we'll talk about how we get these other formulas. Really, so this is the same as cosine theta plus theta, which that would be using that difference formula up here. We would use formula 3 and 4 to get these other 2 versions of this formula. And we'll verify those. It says at the end of this lesson. We'll do it in class. It's not a proof or anything. It's just so you can have them. And so then the tangent of 2 theta, we're going to use that formula. So it's just knowing these formulas, being able to substitute into them. So cosine theta is 12 divided by 13, and theta is in quadrant 4. We need to find the values of sine 2 theta, cosine 2 theta, and tangent 2 theta. So first, cosine theta is 12 over 13, and theta is in quadrant 4. So let's see. So theta is in quadrant 4, so we'll say like this is our angle theta. And we know the cosine of theta is 12 divided by 13. So that value is 12. The hypotenuse is 13. If we do the Pythagorean theorem, trust me when I tell you we get 5. Well, negative 5 because the value's in quadrant 4. So negative 5. So we need to find sine 2 theta, cosine 2 theta, and tangent 2 theta. Cool. So first, sine 2 theta is 2 sine theta cosine theta. So we know the sine of theta, if we look at our triangle here, we know the sine of theta is going to be -5 divided by 13. We already know cosine theta. We don't need to write that. And we know tangent theta is equal to -5 divided by 12. So now 2 sine theta cosine theta is going to be 2 times -5 divided by 13 times 12 divided by 13. And all of that seems like it is, what's the -120? So -120 divided by 169. Does that simplify? Nope. Let's just leave it at that. Cool. So -120 divided by 169. Fantastic. So then cosine 2 theta is going to equal, I forget these formulas all the time, it's cosine squared theta minus sine squared theta. So, or is that better when we can use? Yeah. So anytime you can write it in terms of one trig function, I recommend doing that one. So we're going to do this one, 1 minus 2 sine squared theta. So I guess we could have done 2 cosine squared theta minus 1. So let's go with 2 cosine squared theta minus 1. And again, we know the cosine of theta is 12 over 13. So we're going to have 2 times 12 divided by 13 squared minus 1, which is 2 times 144 divided by 169 minus, so subtracting 1 is like subtracting 169 divided by 169. And so that is 288 over 169 minus 169 over 169, which equals, and you do all of this in the calculator and give me a simplified fraction. That is, I like doing the stuff in my head, so we'll say 121 divided by 169. Cool. 121 divided by 169. And then the tangent of 2 theta is going to equal 2 tangent theta divided by 1 minus tangent squared theta. So 2 tangent theta divided by 1 minus tangent squared theta. And again, all we're doing is substituting into this formula. We know the tangent of theta is -5 divided by 12. So there's going to be 2 times -5 divided by 12, all divided by 1 minus -5 divided by 12 squared. Let me get some room here because I'm running out of real estate. So let me erase the stuff we did for cosine. If you need to, go back and rewind the video so you can see it. My apologies. So in the numerator, we get we're going to get -5 divided by 6 because these simplify to be 1 over 6. So -5 over 6 divided by 1 minus 25 divided by 144, which is the same as 144 minus 25 divided by 144. So we know the whole keep, change, flip thing, right? So that's going to be equal to -5 divided by 6 times 144 divided by 144 minus 125 is 119. Those are some ugly numbers. So let's just throw this into a calculator and simplify. So -5, So -5 divided by 6 times 144 divided by 119. I get -120 divided by 119. Cool. Yeah, because 6 goes in 144 24 times. That makes sense. So -120 divided by 119. So for each of these formulas, all we did was apply the actual formula and use our right triangle trigonometry to find the sine, cosine, and tangent so that we could use those double angle formulas. For number 7, we have sine x plus cosine 2x equals 0. So the problem here is the cosine 2x. So we're going to turn that into something useful. Now, the key to what we should use is this sine x. Because we have a sine x here, we want to use the identity that has a sine in it. So we're going to use the 1 minus 2 sine squared. So this is going to be the same as sine x plus 1 minus, was it 2 sine squared? Yep. 1 minus 2 sine squared x equals 0. And so now we're back to doing the trig equations that we did in the first section. We can multiply everything by -1 to make stuff positive, the sine squared positive. So that would give us 2 sine squared x minus sine x minus 1 equals 0. And if we factor that, what multiplies to be 2 sine squared x? That's 2 sine x times sine x equals 0. So now we need -1. So how do we get a negative sine x here? We're going to need to have 2 sine x plus 1 and sine x minus 1, because that's going to be a negative 2 sine x. That's going to be a positive sine x, and that will give us a negative sine x. And so remember, when it equals 0, we're either going to have 2 sine x plus 1 equals 0, which means that sine x equals -1/2. So x is sine inverse of -1/2, which means we get negative pi over 6, or we get sine x equals 1, so x equals sine inverse of 1, and so x is pi over 2. Plus all of the angles coterminal with it, but we'll just say negative pi over 6 and pi over 2 for right now. So again, what we did here was we used the double angle formula to turn this into something that only had a sine, so we could solve that equation. If this sine x had been cosine, we would have used this formula instead, because we want to have one trig function whenever possible in our equation. And so the last one is reduce cosine 3x to cosine x. Well, let's see. So first, we can say cosine 3x is equal to cosine 2x plus x. And cosine, so cosine 2x, we have, we want to reduce this to just cosines. So we're going to use this one for cosine 2x. And way at the top, remember, cosine of a sum is going to be cosine A, cosine B minus sine A, sine B. Turning that only to sines is going to be a problem. We'll see though. So we're going to get cosine 2x cosine x minus sine 2x and sine x. And so now we know cosine 2x is so cosine 2x is 2 cosine squared theta minus 1. So we're going to have 2 cosine squared x minus 1 times cosine x minus sine 2x is 2 sine x cosine x. And so the sine 2x turns into that, and sine x is just going to hang out at the back. So we end up with 2 cosine squared x minus 1 times cosine x minus 2 sine squared x cosine x. Now remember that sine squared x is equal to 1 minus cosine squared x. So we're going to have 2 cosine squared x minus 1 times cosine x minus, now again, sine squared is 1 minus cosine squared. So 2 times 1 minus cosine squared x times cosine x. And we could factor a cosine out of this. So we get cosine x times 2 cosine squared x minus 1 minus 2 plus 2 cosine squared x. Where I get the -2 plus 2 cosine squared x is we multiply -2 times 1 and -2 times negative cosine squared x. And so we simplify this and get cosine x times 4 cosine squared x minus 3. All right. So that concludes our video on sum and difference formulas and multiple angles. For all of these, we're just using one of these, 5, 11 identities. And again, you'll be given these. You do not need to multiply them. Thanks for watching.